Okay, question 8 is your r sine theta plus alpha question, but we can't start it yet. We can't start it straight away because it's not in the form that we need. We need to change this sine 2 theta first. We're going to use the double angle formula, which says that that's equal to 2 sine theta cos theta. I'm also going to change sec theta into 1 over cos theta and cosec theta into 1 over sine theta. And I'm going to do that all in one go. So we've got 3 sine 2 theta. That's going to be the same as 6 sine theta cos theta over cos theta instead of times by sec theta, plus 4 sine 2 theta is going to be 8 sine theta cos theta. And again, instead of timesing by cosec theta, I'm going to put that over sine theta. And you can now see that this cancels and this cancels, so we're left with 6 sine theta plus 8 cos theta. And we want that to equal r sine theta plus alpha. Now we can use the addition formula on this and rewrite that as sine theta cos alpha plus sine alpha cos theta. And now because these are identical, I should have done an identity sign there. These are true for any value of theta. So if we choose a sensible value of theta to make some of this reduce down, we'll be able to work out what alpha and r is. So when theta is equal to 0, sine theta is equal to 0 as well, and cos theta is equal to 1. So this right hand side reduces down to 8 times 1. That needs to be the same on the right hand side. So that's going to equal, this will disappear as well, this will be equal to 0. So it's going to equal r sine theta times 1 again. So just r sine theta. Similarly, when theta is equal to 90, this will stay because sine of 90 is 1. So we're going to get 6. The next term is going to be 0, is equal to r cos alpha. So we can now say that sine alpha is equal to 8 over r, and cos alpha is equal to 6 over r. And if we relate that to a right angled triangle, I'll put alpha here, we've got sine is opposite over hypotenuse, so I can put my 8 here and the r here, and cos is adjacent over hypotenuse, so the 6 can go there and the r is already in the right place. So this is now right angled triangle. We can use Pythagoras. R is going to be equal to the square root of 6 squared plus 8 squared. Or you might spot that it's a 3, 4, 5 triangle, a multiple of that, and r is going to be 10. Alpha is going to be equal to the inverse tan of the opposite, which is the 8, over the adjacent, which is 6. And if we work that out on our calculators, inverse tan of 8 over 6 is 53.13, 53.1 to 3 significant figures. So therefore, the equation or the function can be written as 10 sine theta plus 53.1. That's what they were looking for part 1.